Hello everyone and welcome to another in our revisited series of presentations from iFormulate. My name is David Calvert and what will follow in the next few slides is a recording that we made of a presentation for the World Bioprotection Forum conference which took place in India at the end of 2022. Just to give you a little bit of background, I believe I first met Dr. Minshad Ansari of Bionema in 2016. And since then, we've discussed many times how formulation can move forward biologicals. And I think we've both been pleased with the progress that has been made since then. And I would like to congratulate him on the efforts he's made to try to move forward the regulations with regard to biologicals. So at that point, I think I should stop now. And rather unusually, I will hand over to myself. I hope you enjoy what follows. And of course, if you have any questions, then please do get in touch with either myself or Jim Bullock at iFormulate. And with that, bye-bye. Hello everyone, my name is David Calvert. I'd like to start just by thanking the organisers and Minshad in particular for asking me to speak to you today, and also send my apologies that I cannot be there in person or with you virtually online. I'm going to talk today about advanced formulation for biologicals, and I looked back and I believe I met Minshad for the first time in Greenwich in the UK in 2016. And when I spoke to the audience with a brief pitch about formulation, I got a series of blank faces looking back at me. I think it's fair to say that formulation for biologicals has come a long way in the last 6 years. And I believe that the time is right now to talk about how it can take biologicals and biocontrol agents a step further in terms of trying to achieve the objectives that no doubt you've been speaking about at this conference. How am I going to do that? Well, the programme today, I'm obviously going to give you a few introductions. I'm going to talk a little bit, although I've said formulation is now well accepted, I just need to talk a little bit about what formulation is, and then talk about different elements. So if you're going to formulate, you need to characterize your active, and I'll give you two examples by what I mean about that with Bt and amyloliquefaciens. Then I'm going to talk about how you can use formulation to do structures with an example of a floating granule. Talk about encapsulation, which is talked about an awful lot in biologicals and has been a big focus, but talk about also about release and use natural oils and cyclodextrins. And then the real skill of formulation about combining functionality and an example of UV and rain resistance and how that's been formulated for via a patent. I guess just as an introduction about iFormulate, we're a two-man consultancy which was formed in 2012. It's myself and Jim Bullock, who you can see there on the slide. The majority of our work is consultancy. A large amount of that is done under NDA. So what I'm talking about today with you is public domain information, because a lot of our work for clients is done under NDA. We help with strategic looking at formulation, and we do a lot of skills training as well. We don't just work in agrochemicals, we cover all formulating industries, and in many ways that's one of our strengths in terms of being able to see what's happening in other industries and bringing that to our clients. Some definitions of formulations. While there are many different ones, people talk about it as being a finished product suitable for sale. It is a complex and a mixture, often consisting of more than one phase. Other people may just talk about formulation as being a recipe or composition containing one or more of the active and functional ingredients. It is, let's not forget, also a process to combine ingredients in the laboratory and importantly in the manufacturing plant. And I think there's a lot of work there to be done on biologicals, how you can scale up and achieve the volumes time after time that's going to be needed to achieve a bigger market share. And we would say formulation is an enabling technology, and previously it's been talked about as being an art, but it is becoming more and more of a science that allows the product to be made safely and effectively. It isn't easy though, and if we look at a formulation triangle, and here I've tried to show you, you've got a functional ingredients, you've got structure, and you've got processing, and trying to balance all of those leads to the optimum properties and performance. So what is the perfect formulation? It's a good question. I've tried to come up with one definition for you, and that definition is it delivers the right active to the right place in the right amount at the right time. And I think that's a good definition, not just for agrochemicals, not just for biologicals and agrochems, but for formulation in all different sectors. And I'm going to try and demonstrate what I mean by that with a few examples for you. So the right active, what do I mean by the right active? And to give you a couple of examples, well, let's talk about something you will all know about, Bacillus thuringiensis, BT. Most widely used microbial insecticide. I don't think I need to tell anyone in the audience that. It's a spore-forming bacteria, and during that sporulation, it synthesizes insecticidal crystalline proteins, or what you might know as ICPs. They are, in essence, the toxic element that can, and they're very specific at times, be toxic to more than 3,000 different insecticides. So, although you have a product which you say contains BT, is for the formulator, the actual active, the one that's doing the business, the ICP? I would argue that it probably is, because that's the toxic element. So, do you need to look after BT, or do you need to look after the ICPs? I think experience would show it's really the ICP that you need to be looking at. And then let's look at Bacillus amyloliquefaciens, something that's becoming more. It's again spore forming, a rod-shaped and a gram-positive bacteria. As with everything, a number of different strains used in agriculture to control this time it's a fungicide. All of the strains synthesize antimicrobial compounds and lipopeptides, etc., but different amounts, different types of lipopeptides. When we look at some of the commercial products, some of those retain those antimicrobial compounds, while others only contain the spores, and I'll show you an example of that. So in that case, what is actually the active? Is it the actual spore, or is it the lipopeptides and the antimicrobial compounds that are synthesized? And again, that's important for a formulator to know. So as an example, let's have a look at two of the most well-known commercial products on the marketplace. We've got double nickel 55, which is strain D747, and that's marketed in the US by Certis Biologicals. And then we have Serifel, which is a different strain, MBI 600, and it is a BASF product. So what do they say about double nickel? Well, they say it's antifungal, it's antibacterial, it does growth promotion. It helps to trigger various responses in the plant, and it works also by excluding other fungus. What about MBI 600? Well, MBI 600 they state it produces antifungal metabolites. It's still got this physical exclusion and nutrient competition. But if you look at the description of these two, this one, they deliberately remove the antifungal metabolites and let the bacteria actually grow them during sporulation. So a different approach, and this one they claim is more specific, but again, I'm not going to comment on that, but just it's interesting that the actual active in the two products, in double nickel you have, I suppose you have two different things, whereas in Serifel you have the actual bacteria itself. So what about delivering it to the right place, and where does it go? Well, an example of this, a patent in 2017 around, again, BT, but it's a great patent in a way to demonstrate the power of formulation. It contains BT, but it has a floating agent, a disintegrating agent bound to a substrate, and the substrate has to be dense, so it's going to sink. It can have another insecticide, methoprene is specifically mentioned, and the granule itself sinks, immediately releases Bt, and then the remaining granule starts to disintegrate and releases Bt as it rises through the water column. They highlight a number of different floating agents, perlite, vermiculites, and synthetic polymer. They have binding agents, which are a range of water-soluble polymers. The substrate that they have in the center, granules, sand, resin, pellets, and clays, and a number of different disintegrating agents. So a very complex formulation, and they give a number of examples, and it can be structured in many different ways. I've just given to you here an example of one where we've got here in the middle, we've got the substrate with that optional insecticide that we talked about, and then they have different layers of binding agent, disintegrating agent, floating agent. In this particular example, the Bt was very much on the outside, so as I said, immediately released, but then as it goes through the column, more gets released, and this optional insecticide gets released as that starts to come through the column. So a really good example of a structured formulation. So what about the right amount? So you need to deliver, if you're doing formulation, you don't want to release too much. That's overuse and actually a waste of your raw material. But obviously you need to do enough to deliver the effect. So let's have a look at what we might use on that respect. And I'm going to use as an example here cyclodextrins. So cyclodextrins are actually polysaccharides, a different family. They have a cage-like structure, and they're used in food and pharmaceuticals quite widely, and they're used often to improve solubility, but also to control the release of products. And the most commonly used is beta-cyclodextrin. But there are a whole range of different structures, and you can tailor the structure depending upon what you wish to encapsulate, solubilize, and obviously to release. And this is just an example of beta-cyclodextrin, and here's the structure that you'll see, and the interior is hydrophobic, and you've got a secondary face. A good review there from 2004, which again gives you a good example of how long this technology has been known. But it's been used outside of food and pharmaceuticals, and it shows some promise in our agrochemicals. Here we have a patent just from 2020, which is from Adama, and you may say, okay, well, they're not the biologicals, but they're starting to see it with conventional, in this case fungicide and insecticides, and they're claiming this time, because of the solubilization, it's got increased penetration, increased uptake, and increased absorbance. But also we've seen it being used in biopesticide compositions, and this was another patent from 2021 from Kimitech, and they're talking about it being used with essential oils and cinnamaldehyde, and in their case they're claiming that the cyclodextrins help to encapsulate the cinnamaldehyde. How did they demonstrate that? Well, they had two functions. You'll know about repellency of whitefly and then the prevention of them laying eggs, the whitefly, and they showed the free one, initially 45.5, the encapsulated product about the same, but after 24 hours it was the free one was only repelling, had 64%, but the encapsulated had 78% effectiveness. And again, preventing from laying eggs, they saw a improved performance after 24 hours. In fact, an improved performance after 12 hours. And this is from a paper really showing where the formaldehyde is encapsulated in there, but it is slowly but surely released. So we're releasing it in over the right time period. But what about at the right time? Well, in a way, the last one was also about the right time, but I've got this example about maintaining activity. And again, BT, so a lot of activity in the BT area. Another patent, this time from Dow, and they talked about combining propylene glycol, specifying the molecular weight, and propylene glycol was providing rain resistance to the formulation, and then a polyphenol which was providing UV resistance. And what they claimed was that in their formulation, normally you would be expecting PEG and polyphenol to aggregate together and to see actually no benefit in the final formulation from either of those. Whereas what they showed, and surprisingly, was that the two together can actually provide you with both UV resistance and rain resistance, both of which have been issues with BT formulations. Say, efficacy was remained after UV exposure and rainfall. So in this brief presentation, I hope what I've tried to give to you is a feeling that the challenge and the opportunity for biopesticides is not just stability in can. That's been the focus of so much work, and perhaps an over-focus on that. If biocontrol agents are going to develop and take over a greater market share, then efficacy, there is no doubt, will need improving, and therefore formulation will play a role. You will see, and you should not be ignoring the formulation technologies from the conventional crop protection technologies, because they provide opportunities and they will be increasingly adopted. So I think I've just about come bang on time on my 15 minutes. I'd like to thank you for listening. Say again, my apologies. If you have any questions based on the presentation, then all of the contact details are there to contact either myself or Jim, and you can go to our website www.iformulate.biz. But thank you for your attention and enjoy the rest of the conference. Thank you very much. Bye-bye.